Hello everyone, my name is Dex Kamitan, and today we're going to talk about Cronbachs Alpha in SPSS. In this video, we're going to talk about its definition, how to interpret it. We are also going to talk about its limitation, and then later we are going to head on over to SPSS to see how to compute for Cronbachs Alpha. So, Cronbachs Alpha is a convenient test used to estimate the reliability, otherwise known as internal consistency, of a composite score. So, it's more commonly used when you have multiple Likert questions or in a survey or questionnaire that form a scale and you wish to determine if the scale is reliable. Now, you may ask, what on earth does that mean? Well, let's start with reliability. Say you took a survey measuring your attitudes towards COVID-19 vaccines. Your attitude scores would be highly reliable or consistent if it produces the same or similar results when the same individual retakes the survey under the same conditions. However, say an individual takes the said COVID-19 vaccines attitude survey twice, let's say back to back, and one score shows positive attitudes towards vaccines and the other scores shows negative attitudes towards vaccine, that measure would not be reliable at all. Cronbachs Alpha gives us a simple way to measure whether or not a score is reliable. It is used under the assumption that you have a unidimensional scale. So a measure is said to be unidimensional if its items measure a single latent trait or construct. So for the COVID-19 vaccines attitude survey, you might have 9 questions all asking different things, but when combined would be said to measure overall attitudes towards COVID-19 vaccines. So there are different reports about the acceptable values of alpha. Here is one from Conting et al. In 2009. As you can see here, the general rule of thumb is that a Cronbach alpha of 0.7t and above is good, 0.8 and above is better, and 0.9 and above is best. Now, theoretically, Cronbach alpha's results should give you a number from 0 to 1, but you can actually get negative numbers as well. A negative number indicates that something is wrong with your data. Perhaps you forgot to reverse score some of your items. So, Cronbach alpha does not come without limitations. So now, first, Cronbach alpha is not a measure of dimensionality, nor a test of unidimensionality. In fact, it's possible to produce a high alpha coefficient for scales of similar length and variance, even if there are multiple underlying dimensions. So to check for dimensionality, you'll perhaps want to conduct an exploratory factor analysis or PCA. Also, Cronbach alpha is not a measure of validity or how well a test measures what it claims to measure. Also, a larger number of items can result in a larger alpha and a smaller number of items in a smaller alpha. And sample size can also influence your result for better or for worse. In short, you'll need more than a simple test of reliability to fully assess how good a scale is at measuring a concept. However, it's still a widely used measure. So if your panelists, let's say, are asking for proof that your instrument was internally consistent or reliable, Cronbachs Alpha is a good way to go. So now that we have discussed the basics and how to interpret Cronbachs Alpha, let's head on over to SPSS to see how it is computed. Let us say that we have created a 9-question questionnaire to measure attitudes towards COVID-19 vaccines. Each question was a 5-point Likert item from strongly disagree to strongly agree. So in order to understand whether the question in this questionnaire all reliably measures the same latent variable, that is attitudes towards vaccine or attitudes towards COVID-19 vaccines, that is, a Cronbach alpha will be run on a sample size of 15 college students. So in SPSS statistics, the 9 questions have been labeled QU1 to QU9. All right. So in order for you to run Cronbach Alpha, you just need to click on Analyze, then go to Scale, then select Reliability Analysis. So you'll be presented with the following reliability analysis dialog box. So in order to, the next thing that you have to do is to transfer the variables Q1 to Q9 into the items box on your right. So what you can do is either drag the items here or click on the arrow button. All right. So leave the model option as set as alpha, which instructs SPSS statistics to run Cronbach Alpha. And note, if you want to provide a name for the scale, enter it in the scale label here. Since this only prints the name you enter at the top of the SPSS statistics output, it's certainly not essential that you do. And in this example, we won't be uh, indicating any scale label. So click on the statistics button. You'll be presented with the reliability analysis statistics dialog box. Select item or item, scale, and scale if items deleted options in the descriptives area. And for the correlations option in the inter item area. So click on continue. This will return you to the reliability analysis dialog box. Click on OK. This will generate the output. So the SPSS statistics produces many different tables. The first important table is the reliability statistics table that provides you the actual value of Cronbach Alpha. As you can see here, for our example, Cronbach Alpha is 0.310, which indicates a low level of internal consistency for our scale with this specific sample. In fact, based on Conting et al. In 2009, this alpha is not non-acceptable. You may need to improve your items or increase the number of items or even increase your sample size to get a higher alpha. So the item total statistics table presents the Cronbach alpha uh, uh, Cronbachs Alpha if items are deleted. So this is the final column. So this column presents the value that Cronbachs Alpha would be if the particular item was deleted from your scale. We can see that removal of any questions except question 9 would result in question 9 and question 3, that is, and even question 7 will result in a lower Cronbach's alpha. Therefore, we would not want to remove these questions. So removal of questions 3, 7, and 9 would lead to a small improvement in Cronbach's alpha. This might lead us to consider whether we should remove these items. So Cronbach alpha simply provides you with an overall reliability coefficient of a set of variables. For example, your questions here. If your questions reflect different underlying qualities or other dimensions, for example, attitudes towards certain brands of vaccines and attitudes towards vaccine in general, Cronbach alpha will not be able to distinguish between these items. In order to do this, uh, you will need to check the reliability using Cronbach's alpha, or before that, you will first need to run a test such as principal components analysis, or PCA. And don't worry, we will talk about how to conduct PCA in the future. Again, my name is Dex Kamitan, and thank you for watching.